Right now, somewhere out past the orbit of Pluto and getting further away every single second, there is light, ordinary light. It bounced off the face of a dying man in a hospital room in Los Angeles back in February of 1988, slipped out through the window, and it never stopped. It's still going. It will keep going, in a straight line, for longer than the Earth itself has left. That man was Richard Feynman. And here's the question that is going to sound completely insane for about the next 30 seconds, until it suddenly doesn't. Is he actually gone? Because physics, real physics, the kind you can write equations for, has a very strange answer to that. And it is not the answer you were taught in school. So stick with me, because by the end of this video I'm going to show you the exact idea, straight out of Einstein's own letters, that suggests Feynman never truly left at all. Not as a comforting metaphor, as geometry, as a fact about the shape of reality. Let's get into it. First, you need to know who we're even talking about, because it genuinely matters here. Richard Feynman wasn't just a physicist, he was the physicist that other physicists were a little bit scared of. He won the Nobel Prize in 1965 for basically rewriting how we understand light and matter, a theory called quantum electrodynamics, which to this day is the most accurately tested theory in the entire history of science. He cracked safes at the top secret laboratory that built the atomic bomb just for fun, just to prove he could. He played the bongos, he taught himself to paint, and decades later, when the Challenger space shuttle exploded and a whole committee of experts couldn't clearly explain why, it was Feynman who dropped a little rubber O-ring into a glass of ice water on live television and showed the entire world the answer in about 10 seconds flat. The man's whole personality could be summed up in a single sentence. Why does it work like that? So when cancer finally caught up with him in 1988, and the story goes that his last words were something like, "I'd hate to die twice. It's so boring." The world basically agreed on one thing. A light had gone out. Done. Over. Except, hold on. Here's where the physics quietly raises its hand at the back of the room. Because in all of physics, every equation we've got, every single law that has ever survived an experiment, there is no term for gone. There is no variable for poof, cease to exist. The very first law of thermodynamics, the one they teach you before anything else, says that energy cannot be created, and it cannot be destroyed. It can only change form. So when Feynman died, all the energy that was running his body, the electrical storms firing across his neurons, the heat, the endless chemistry, none of it vanished. It couldn't. It dispersed. It became warmth in the room, then heat in the air. Then it radiated outward into the building and beyond. Every single joule is still out there somewhere, doing something. The universe kept every receipt, and it's not just heat either. Think about this. Feynman gave lectures. He went on television. That Challenger hearing, the ice water, the O-ring, that was broadcast. And the moment it was broadcast, his voice and his image left the antenna as electromagnetic waves, moving at the speed of light, and those waves did not stop at the edge of the city. They kept expanding outward, past the moon, past Mars, out into interstellar space, a bubble of Feynman's voice growing larger every second. Right now, tonight, while you watch this. In a very literal sense, his voice is still traveling, but I can feel you pushing back already. You're thinking, okay, sure, but that's just energy. That's heat and atoms and radio waves. That's not him. That's not the guy with the bongos and the smirk. And that is a completely fair objection. So let's talk about what him even was in the first place, because this is the part that flips the whole thing over. You, the actual you sitting there watching this, are not made of permanent stuff. The atoms in your body right now are basically rented. You swap out something like 98% of your atoms every single year. The carbon in your muscles, the calcium in your bones, the water in your blood. Most of it wasn't there a few years ago, and it won't be there a few years from now. You have already replaced almost your entire physical body many, many times over since you were a child, and yet you still feel like you. Same memories, same laugh, same you-ness, which means something genuinely wild. You were never the atoms. You're a pattern, a shape that information holds while matter just flows through it, like a whirlpool in a river. The water is always leaving. The whirlpool stays. You're a standing wave that somehow learned to think. So now the question gets a lot sharper. If you're a pattern and not a pile of stuff, then the real question was never where did his atoms go? The real question is, what happens to the pattern? What happens to the information? And this is where modern physics does something that honestly should be 1,000 times more famous than it is. Because quantum mechanics has this rule buried deep in its foundations, and physicists take it deadly seriously. Information is never destroyed, ever. The technical word for it is unitarity, But the idea itself is simple and stubborn. You can scramble information, you can smear it out, you can make it completely impossible to read, but you cannot delete it from the universe. It's like burning a book. It looks destroyed. But in principle, if you could somehow track every single atom of smoke, every photon of light, every tiny bit of heat that came off it, the information about every page is still there, just scattered into a form you can't read anymore. Nothing was actually erased. It was encrypted. And here's just how seriously physicists take this. There was a decades-long war over this exact question, and it centered on the single scariest object in the universe, the black hole. Stephen Hawking argued for years that when something falls into a black hole, its information is gone for good, truly and permanently deleted. And the rest of physics basically said, no, that cannot be right, because if information can be destroyed even once, even a single time, the entire mathematical structure of reality falls apart. This fight got so intense it earned its own name, the black hole information paradox. And in the end, Hawking himself conceded. He agreed the information survives. So think about what that actually means. Physicists were willing to go to war over the idea that not even a black hole, the ultimate cosmic shredder, is allowed to truly erase information. So a human body, a brain, a quiet hospital room in 1988, that doesn't even come close to a black hole. Whatever information made Feynman was scrambled. Yes, encrypted far beyond any hope of ever reading it. But by the laws we actually use to run the universe, it was not deleted. It is still in the ledger. Okay, take a breath here, because we're about to leave the comfortable part behind. Everything I just told you, the energy, the atoms, the information, all of that is real, but you could still turn around and argue it's cold comfort. Scrambled information isn't a person. A whirlpool that stopped spinning isn't the whirlpool anymore, and you'd have every right to say that. So let me finally show you the thing I promised you at the very start. The thing that comes not from mysticism, not from religion, but from the one man who arguably understood time better than anyone who has ever lived. Albert Einstein. In 1955, Einstein's oldest and closest friend, a man named Michaela Besso, died, and Einstein sat down to write a letter to Besso's grieving family. He was an old man himself by then. He would be dead about a month later. And in that letter he wrote something that physicists still quote to this day, because it wasn't just comfort, it was his actual literal view of reality. He wrote that for those of us who believe in physics, the separation between past, present, and future is only a stubbornly persistent illusion. Read that again slowly. The distinction between past, present, and future is an illusion. He was not being poetic. He was describing what his own theory of relativity flat out implies, because in relativity, time is not a river flowing forward and leaving the past behind forever. Time is a dimension just like the three dimensions of space, and all of it, every single moment, exists together, laid out in one enormous, unchanging structure that physicists call the block universe. Let me make that concrete, because it is the whole point of this video. Imagine a film reel. Every frame of the entire movie exists, all at once sitting there, coiled up in the canister. The characters in frame 5 do not stop existing the moment you're watching frame 500. They are still right there on the film. It's just that the projector, your consciousness, your sense of now, is currently shining its light on a different frame. In the block universe, that is what reality is. Every moment of space-time is a frame that exists permanently. The year 1988 did not get destroyed when we moved past it. The morning Feynman won the Nobel Prize is still there, sitting at its own coordinates in space-time, exactly as real as this precise second you are living through right now. We simply don't feel it that way, because our consciousness only ever shines its light on one frame at a time, and it only ever moves in one direction. But the frames don't vanish behind us. They can't. There's nowhere for them to go. So now, let's put every piece of this together, because this is the reveal. When we say that Richard Feynman died, what we actually mean in this picture is that our projector moved past the very last frame that had him in it. That is it. That is all death is here. Not deletion, not erasure, a boundary. The final page of his chapter, but the book still contains the entire chapter. The light that left his face is still traveling outward at the speed of light, carrying his image into deep space, essentially forever. The atoms that built him are still here on Earth, folded back into the world, into plants, into rain, into the bodies of other people. The information that made him is scrambled, but by the deepest law we have, undestroyed, and the entire span of space-time holding every second of his life, the safe cracking, the Nobel Prize, the bongos, the O-ring dropped into the ice water, the very last joke, that whole slice of the universe is still there, permanently, at its own fixed address inside the block. We just can't stand where he is standing anymore. And that is not some comforting story that somebody made up to feel better about dying. Every single piece of it comes directly out of the physics we use to build the satellites over your head and the computer in your pocket and the exact screen you're watching this on. Conservation of energy, conservation of information, the geometry of space-time itself. Feynman spent his entire life asking one question over and over. How does it really work? And the strange, almost unbelievable answer that his own field hands back is this. In a real, physical, mathematical sense, nothing that ever existed is truly gone. It just moves out of our reach. Somewhere far out past the edge of our solar system, the light is still flying. And if Einstein was right, then in the only frame of reference that ultimately counts, the whole of space-time, seen all at once, Richard Feynman is still exactly where he always was. Still curious, still there. If that rewired your brain even a little bit, do me a quick favor and hit that like button, because it genuinely helps this channel reach more curious people just like you. Subscribe if you want more physics that messes with your head in the best possible way. And I really want to hear from you down in the comments. If the past never truly disappears, does that change how you think about the people you've lost? Drop your honest thoughts below. I read every single one. And I'll see you in the next frame.